Hi, everyone. Today we're going to go over 2-4 scatterplot, correlation, and regression. Our key concept, we're going to introduce the analysis of paired sample data. We have these two things that go together. For example, you could say the older people get, the shorter they cut their hair. That's paired data. Now, we don't know if that's true or false, but let's say we want to see if that's true. We would just have this question, and we could start doing some things that would give us some information. We're going to discuss whether or not those two things are correlated. Is it true that the older you get, the shorter your hair gets? It may or may not be true. And the role of a graph called the scatter plot, and provide an introduction to the use of the linear correlation coefficient. We have a value that we can calculate. Also, we're going to provide a very brief discussion of linear regression, which involves the equation and graph of the straight line that best fits the sample paired data. Let's say, for example, I have here, I'm going to say this is age versus hair length. Let's say when kids are less than 1, their hair is really short. And then let's put a dot there. And then they become 3. We haven't cut their hair, so it's growing a little more. And so on and so on. By the time they're 10, their hair is long. So this is the length of the hair. So it's getting longer and longer. But now, at some point, who knows where, maybe out here when they're 40, they decide to get a new kind of hairstyle and they cut it really short. And they keep it short for a really long time. Here, we're trying to see if these paired data form any kind of a line, and it doesn't look like it. It looks like it's going to go up and maybe then it goes down. But we just made that data up. We have to actually start measuring. A scatter plot and correlation. A correlation exists between two variables. We just talked about two different variables, age and hair length, when the values of one variable are somehow associated with the values of the other variable. Here's one thing to be cautious about. The presence of a correlation between two variables is not evidence that one of the variables causes the other. We might find a correlation between beer consumption and weight, but we cannot conclude from the statistical evidence that drinking beer has a direct effect on weight. This is very important right here. Correlation does not imply causality, because many things could have happened. You could have started drinking beer and at the same time stopped exercising and maybe started eating bad. What was it? Was it the beer consumption? Even though your weight went up as you started consuming more and more beer, there's other factors that we haven't taken into consideration. So we can't say that it actually makes something happen. A linear correlation exists between two variables when there is a correlation and the plotted points of paired data result in a pattern that can be approximated by a straight line. A scatter plot, or sometimes we call it a scatter diagram, is a plot of paired XY quantitative, that means numeric, data, and they're saying that we have a horizontal or x-axis and a vertical y-axis. A horizontal, this would be the x-axis, and a vertical, this would be the y-axis. For example, if we had a bunch of values, and we plotted each one, notice we're not putting lines or we're not connecting them, we're just plotting dots from where these points are. We can see that in general, as the waist circumference increases, so does the arm circumference. Sometimes not as much, sometimes more, but we can see that there is a distinct pattern of the plotted points and it suggests that there is a correlation between waist circumference and arm circumference. It's following that line. Now we're going to look at another one. This one is weight and pulse rate. We have weight on the x-axis and pulse rate on the y-axis. And if I pick a point, as my weight goes up, does my pulse rate go up? Well, not necessarily, because here's a high pulse rate with a smaller weight, and here's a smaller pulse rate with a bigger weight. It doesn't seem to be going in any direction. It is just spread everywhere. The plotted points do not show a distinct pattern. So it appears that there is no correlation between weight and pulse rates. This is a problem that I picked from Pearson. It is not a problem in your homework, but it is similar. And I wanted to show you how to use StatCrunch, because we could plot all these points. We can see here that we're plotting tar versus carbon monoxide, okay? But the problem is I don't want to plot every one of these points. So what I can do is, if you look up here in the upper right-hand corner, there's this little box and it says click to copy table. So I'm going to click it and it says open in StatCrunch. That's what I want to do. I want to open it in StatCrunch. And when I do that, all the data from this table here, notice, here's my data. You can do this without using StatCrunch, but I'm going to use StatCrunch because I think it will make it a little easier. I'm going to go up here and I'm going to graph a scatter plot. And my x-axis, we can see, is tar. So let's pick tar. And my y-axis is carbon monoxide. And I don't think there's anything else I really want to put here. No, I'm good. And then I hit compute. And there is my graph. Let's look at A. We can see pretty clearly that it isn't A. How can we tell? I don't even have to make it bigger. I can see that we're starting up here and we're coming down, right? The bigger tar gets, the smaller the carbon monoxide gets. But that's not true with the graph that we have here. So I'm going to say, no, it's not that one. We have B. It's so not B, because B is just going all over the place. I don't have any kind of pattern that looks like B. Let's cancel B away. Now, C and D both have possibilities. How can we tell? Well, we can look at certain identifiers, like we have this one point out here, which they both have that. But notice these points right here and these points right here. These are going side to side and these are going up and down. I'm going to guess it's D, but we can even do a little better than that. We can open this up. So we can just click this open, more as big as we want. Let's go back and get our plot. And yeah, it's exactly like we saw it when it was small. These dots don't match. This doesn't really seem to match very well. And another thing I can do, instead of making things bigger and smaller, I can do this, which just pulls it completely out. Let's look at these next to each other. There's my same 2 points. And then see these 2 points right here? This one right here, these are horizontal and we have the same ones here. Everything looks exactly identical. My answer is D. And I don't really have to do much more. I just want to show you how you can use StatCrunch instead of plotting points.